The next thing we have in this section after we complete the domain part is we have to simplify rational expressions. Simplify means we're going to reduce them, multiply them, and divide them. All of those basically have two steps: factor, cross out. That's what we're doing. So in this first example, I ask you to simplify x cubed plus 3x squared over x plus 3. I'm going to write it a little bigger. You cannot cross out the pieces, so when you get ready to work this one, you have to factor first. The denominator does not factor. The numerator does factor. It has a greatest common factor of x squared, so we can take an x squared out of that, and it leaves me with 1x left over plus 3. And that's what it would look like when I factor it. After that, we'll reduce it. Oops, excuse me. We have an x plus 3 on the top and an x plus 3 on the bottom, so they cancel out, and your answer would just be x squared. The multiplying ones work exactly the same way. You factor and then cross out. So for this particular problem, you have x plus 3 over x squared minus 4 times x squared minus x minus 6 over x squared plus 6x plus 9. Do not multiply. I know the directions say multiply, but don't multiply them. All you want to do is factor out all the pieces. Okay, so I'll change to blue where you can see the factor step. So the first one is x plus 3. I'm just going to bring that one over. Then you have x squared minus 4. So that's the difference of squares. That would be x and x, 2 and 2, 1 positive, 1 negative. Okay, and the next one that you have is a basic trinomial. So you have x and x. The factors of 6 that subtract to give me 1 are 3 and 2. My signs are different. The 3 is negative. Across the bottom, I have another easy trinomial. The factors of 9 that add to give me 6 are 3 and 3. They are the same sign, both positive. Okay, so that's how everything would factor. Now your rule says that you can reduce, but you don't have to reduce right over each other. You can reduce anything in the top with anything in the bottom. So if I look at these blue terms that are factored, I see an x plus 3 here and an x plus 3 here. Now it's very tempting to go ahead and factor out the other x plus 3, but don't do that, because remember they only factor out, they only cross out in pairs. So now that that x plus 3 is out of the top, there's not another x plus 3 to cancel out. So that x plus 3 is left in the bottom. Okay, the other factor that crosses out is you have an x plus 2 here and an x plus 2 here, and that looks like it. So your final answer for this one would be an x minus 3 in the top, and across the bottom you're going to have an x minus 2 and an x plus 3. That's your answer. Now you'll say, well, can I multiply that out across the bottom? You certainly could, but you can also leave it in its factored form. Okay, looking at this last one, it's divide. And what you have to remember about divide is when you're dividing two fractions, you keep and change and flip. Okay, so I'm going to keep this first fraction, x squared minus 2x plus 1, x cubed plus x. I'm going to change it to multiply. And I'm going to flip the second one. Keep and change and flip. Okay, once you do that, it's exactly like the multiplying problem that you see above. You're going to factor everything out, and then you can cross out. Okay, so when I start factoring, I'm going to get the factors of 1 that add to give me 2 are 1 and 1, and they're the same sign, both negative. On the bottom I have a common factor of x, so this is a GCF. I take out the x, and that leaves me with x squared plus 1 left over. Going to the next fraction, they have a 3 in common, so if I factor out the 3, that leaves me with an x squared plus 1. And across the bottom, the factors of 2 that subtract to give me 1 are 2 and 1, and the 2 is positive. So that's how it would factor. Now then, remember, anything in the top, any common factor in the top will cross out with any common factor in the bottom. So an x squared plus 1, those would cross out. One of these x minus 1s would cross out, but they can only cross out a pair, so that's how that would be left. And I don't see anything else that crosses out. So my final answer for this one would be a 3 in the top and an x minus 1 in the top. That's what's left behind. And an x in the bottom and an x plus 2 in the bottom. Now that's a great answer. You could simplify it further by distributing, or you can leave it in its factored form. Either one is fine.